Witnessing planet formation. Strange swirls around an infant star. What are those intriguing spirals surrounding a young star? It seems we might be witnessing the birth of a planet in real time. Astronomers have observed what looks like a planet in the process of formation, creating a complex design within a disk of gas and dust encircling a youthful star. This discovery of a spiral structure could significantly enhance our understanding of how planetary systems, including our own solar system, originated. The young extrasolar planet, commonly referred to as an exoplanet, is generating a spiral arm pattern in the protoplanetary disk of the 10-million-year-old star aged 135344b, also known as SAO 206462, situated in the Scorpius OB2-3 star-forming region. While 10 million years may not seem particularly young, it's essential to remember that our Sun is considered middle-aged at approximately 4.6 billion years old. The identification of this potential planetary architect responsible for the swirling spiral was achieved using the Very Large Telescope, VLT, and its Enhanced Resolution Imager and Spectrograph, ERIS, instrument. This may mark the first occasion that astronomers have directly observed a planet actively forming within a protoplanetary disk. Francesco Maio, the study's lead researcher from the University of Florence, stated, "We will never witness the formation of Earth, but here, around a young star 440 light-years away, we may be watching a planet come into existence in real time." Maio and his team estimate that this emerging planet is roughly twice the size of Jupiter. It orbits HD 135344b at a distance comparable to that of Neptune's orbit around the Sun, which is about 30 times the distance from Earth to the Sun. As this potential planet carves channels into the protoplanetary disk of HD 135344b, it is also accumulating material to support its growth. ###the baby exoplanet collects stellar remnants. Stars are born from dense, cool regions within vast clouds of interstellar gas and dust, which collapse under their own gravitational pull. As these stars continue to evolve, swirling clouds of gas and dust, known as protoplanetary disks, form around them. It is within these disks that planets are created. Astronomers predict that as these young worlds form, they gather material to increase their mass, resulting in intricate structures such as rings and channels that resemble the grooves of a vinyl record, as well as spirals akin to the spiral arms of the Milky Way. However, capturing these exoplanet sculptures has proven to be quite challenging. For instance, astronomers had previously detected the spiral structure of HD 135344b's protoplanetary disk using the VLT spectropolarimetric high-contrast exoplanet research (SPHERE) instrument, but they had overlooked evidence of a planet responsible for this structure. Thanks to ERIS, the VLT and its operators were able to delve deeper into this protoplanetary disk, uncovering a prime suspect for its shape, a concealed exoplanet sculptor. This potential baby planet is located at the base of one of the disk's spiral arms, precisely where scientists had anticipated such a spiral sculpting infant planet would reside. ###A turning point in detection. Maio elaborated, "What makes this detection potentially a turning point is that, unlike many previous observations, we are able to directly detect the signal of the protoplanet, which is still highly embedded in the disk. This gives us a much higher level of confidence in the planet's existence, as we're observing the planet's own light." The findings of this research were published on Monday, July 21st, in the journal Astronomy and Astrophysics. Join our space forums to continue discussing space topics, including the latest missions and night sky events. If you have any news tips, corrections, or comments, feel free to reach out to us at community@space.com. Robert Leah is a science journalist based in the UK, with articles featured in publications such as Physics World, New Scientist, Astronomy Magazine, All About Space, Newsweek, and ZME Science. He also writes about science communication for Elsevier and the European Journal of Physics. Rob holds a Bachelor of Science degree in Physics and Astronomy from the Open University in the UK. Follow him on Twitter at ScienceF1RST. Spotted. Newborn planet and Betelgeuse's hidden companion revealed. The recent discovery of a newborn planet offers an extraordinary insight into what our Earth may have looked like 4.5 billion years ago. For the first time, astronomers have observed a planet in its formative stages, emerging from a swirling disk of dust. Francesco Maio, a researcher from the University of Florence in Italy, expressed the significance of this finding, stating, "While we can never directly witness the formation of Earth, we might be observing a planet's birth in real time around a young star located 440 light-years away." Utilizing the European Southern Observatory's Very Large Telescope in Chile, astronomers focused on a young star known as HD 135344b. Around this star, they identified a disk of dust that radiates outward in spiral arms, reminiscent of the Milky Way's structure. Nestled within one of these spiral arms, they discovered a protoplanet, a collection of rocks and dust that has begun to merge into a planet. This protoplanet is estimated to be twice the size of Jupiter and is situated at a distance from its star comparable to that of Neptune from the Sun, approximately 30 times the distance between Earth and the Sun. Although such dust disks have been previously observed around other stars, astronomers have long speculated that the spiral patterns, rings, or gaps within them were indicative of forming planets. However, this is the first time an infant planet has been seen actively shaping the dust around it. Maio noted, "What makes this detection potentially groundbreaking is that, unlike many earlier observations, we can directly identify the signal from the protoplanet, which remains deeply embedded in the disk. This enhances our confidence in the planet's existence, as we are witnessing the light emitted by the planet itself." In a separate study released on the same day, astronomers made another intriguing discovery regarding Betelgeuse, one of the most recognized stars in the night sky, located in the Orion constellation. They found that Betelgeuse has a faint companion star orbiting it, which may explain the long-standing mystery of its fluctuating brightness. To investigate Betelgeuse, astronomers employed an instrument called Allopeak on the Gemini North Telescope in Hawaii. Betelgeuse, a red supergiant star, is believed to be nearing the end of its life cycle. At just 10 million years old, it is a mere fraction of the Sun's age, yet it is already in its red supergiant phase, suggesting it could explode in a spectacular supernova within the next few tens of thousands of years. For centuries, observers have noted that Betelgeuse's brightness varies in a regular pattern, leading some to propose that a second, dimmer star might be orbiting it, occasionally obscuring its light. This hypothesized companion star has now been confirmed by researchers at NASA's Ames Research Center, led by Steve Howell. Their findings, published in the Astrophysical Journal Letters, indicate that this companion star is about 1.5 times the mass of our Sun but significantly dimmer than Betelgeuse. It is likely spiraling inward, with a potential collision with Betelgeuse expected within the next 10,000 years. Howell remarked, "Previous studies predicting the existence of Betelgeuse's companion suggested that imaging it would be nearly impossible. These discoveries not only deepen our understanding of planetary formation and stellar evolution, but also raise fascinating questions about the dynamics of celestial bodies." What do you think about the implications of these findings? Could they change our understanding of how planets and stars evolve? Share your thoughts in the comments. Discovering a young gas giant. Insights from protoplanetary disks. Imagine this. A young gas giant, hidden within the swirling depths of a protoplanetary disk, has been lurking undetected for years. The disk around MP-Muse, also known as PDS-66, has long been a mystery, appearing smooth and structureless at millimeter wavelengths. But here's where it gets controversial. New observations from ALMA at 3 millimeters have pierced deeper into the disk, revealing hidden substructures that were previously invisible. These structures include an inner cavity and a ring, challenging our understanding of planet formation and disk evolution. But this is the part most people miss. The presence of these substructures suggests that rings and gaps in protoplanetary disks may be even more abundant than we thought, potentially providing more dust trapping and necessitating high-resolution, high-sensitivity surveys at longer wavelengths. So, what does this mean for our search for exoplanets? And could this hidden giant be just the tip of the iceberg? The implications are vast, and the debate is just beginning. What do you think? Could there be more hidden worlds waiting to be discovered? Share your thoughts in the comments below.